Well, I guess we should start talking about containers in the first place, right? And the whole purpose of containers is to package your application, your service, your code into an immutable form that can be reproduced and deployed at scale. And containers came to solve kind of like a very fundamental problem, which was it was impossible for developers to run the exact same thing that would be running in production or in other environments. With containers, developers came to fulfill that need. When you build a container image and when you run your application in a container, it doesn't matter where you're running it, whether it's your local machine or a remote machine or a cluster orchestrator such as Kubernetes, you're actually running the exact same thing. Down to the OS level libraries, dependencies, everything is packaged and it's immutable. Matter of fact is when you build a container image and you run it, containers are built of layers. And basically layers are states across a timeline of a build process. So when you build a container, you write a Docker file, which when you're talking about Docker containers, of course, Docker is not the only container platform, but it's become the container platform. When you write a Docker file, you basically specify all the different steps that you want to go through for building that container. And each step basically results in a layer. And that layer represents a point in time of that file system, which is why you can cache them and why you can reuse them. And when you run that image, Docker basically builds an ephemeral layer on top of everything, which is where kind of your read writes while the container is running or happening. This is the same in your machine or wherever you're deploying this container. So that's one of the most relevant benefits of running containers. But a container alone doesn't give you a production-ready deployment, right? When you're talking about production readiness, you want to make sure that you can distribute this container to run across many nodes. You want it to scale horizontally. You want to have many instances of this image running at any given time. And when you introduce that level of complexity, that's precisely where Kubernetes and container orchestrators fall in. Basically, they manage containers at scale. And Kubernetes is currently the leading container orchestrating platform. It is a project that is highly influenced by Borg. Borg is the platform that Google built to run their containers, and everything that Google runs is running in a container. And from Borg came Kubernetes, borrowing a lot of the concepts that Borg championed, basically. And Kubernetes, as an orchestrator, basically what it handles is making sure that wherever that you are constantly running the necessary amount of containers that you expect to be running, and that you can leverage a large scale of compute and storage capacity transparently. So when you ask Kubernetes deploy 10 instances of this container, 10 replicas of this container image, Kubernetes is handling everything else. It's handling identifying from this large scale compute cluster and storage network where to run your container based on the container requirements, based on the node's health. And if you're running a container on any one of a distributed set of machines, there's other complexities that have to be considered. How is traffic going to be getting to those containers if they're distributed across an arbitrary set of nodes? And that's where Kubernetes comes in as well. It handles proxying traffic to those containers, the resolution of the name of your services within the Kubernetes ecosystem, securing security of communication between your containers. And Kubernetes, coming from Borg, part of the concepts that it inherited are a strong focus on it being API driven. So Kubernetes, the control plane, gives you an API that you can use. You can consume the API to manage how you deploy your containers across the ecosystem. And it being API driven, it's highly extensible. So it's allowed a huge amount of participants to get involved in developing and delivering new functionality for Kubernetes. So Nginx, for example, has built an ingress controller for Kubernetes. An ingress controller basically allows you to expose endpoints to the outside world and proxy traffic through a single load balancer to multiple sets of services, to multiple services. And the fact that it's all API driven and declarative, because what you're doing is you're writing YAML files to declare how and what you want to have deployed, also made it very friendly for the developers to adopt. And all those all of that has worked towards Kubernetes being the leading orchestrating platform that is currently out there.